All right, last set of practice. It's going to be similar to the set that you did for numbers 30 through 30, or 31 through 40. But so if the directions say find the sum of the series, it says the first and last terms are given, but that's not true. The first term and number of terms are given. So it's going to be very similar to 31, but so we're finding the sum of the series. And we are given our first term, and then our second, and then our third and our fourth, and we're given the number of terms in the series. There's 7 terms. And we want the sum of these 7 terms. So you could, there's only 3 more terms that you need to write out. You could figure out what those 5th, 6th, and 7th terms are and then add them all up. Or you can use, again, the sum of the series formula. And so here, I'm going to start using that one. I think this one's the easiest way to go. 1 minus, what's the rate going to be? Well, we need to use this pattern, this series, to figure that out. So how are we changing each time? Now, they say it's geometric. Well, they don't say it's geometric. But obviously, adding's not going to work because we subtract, 16 to go from, or 14 to go from 2 to negative 12. And then subtracting 14 again doesn't take you to 72. So let's try multiplying. What if we multiply by negative 6? Yep, that takes you to negative 12. Negative 12 times negative 6 is positive 72. 72 times negative 6 is negative 432. So R equals negative 6. So that's going in for R. Notice how I use parentheses around the rate. And then I raise it to the 7th term because we would have 7 terms in this series. And then we do 1 minus the rate. So 1 minus negative 6. So that's the main changes. You got to find the rate. You got to look at the pattern and find what the rate is. And then from there, we are off to the races with our calculator using parentheses, calculating the top. The top gives you 559,874 divided by 7, which gives you 79,982. Excuse me. All right, let's try one more of those. So this is, my pen just died. This is number 43. So again, we're finding the sum of the series. And so when you read number 43, you see that n equals 6. So there's only 6 terms in this series. If you want to try to find the 5th and 6th values, you could do that and then add them all up. This formula also works. It's kind of cool. I give you these formulas, but you could do it both ways here just to kind of see that it does in fact work. I'm going to use the formula. So the sum of, I'll change it right away to 6 terms. N is 6 here. It's going to equal the first term. Using this formula, the sum of a geometric series. First term is 2, parentheses 1 minus, I don't have the rate. I have to raise the rate to the 6th power because there's 6 terms in this series, divided by 1 minus the rate. So we go up here to this series and try to find what, again, it's geometric, I think you'll see, because addition's not going to work. We multiply 2 by negative 2 to get negative 4. Multiplying negative 4 by negative 2 gives you positive 8. Yes, multiplying by negative 2 definitely is the pattern. So the rate is negative 2. Make sure you put that in parentheses. And then just grab our calculator, do the top, and then you'll divide that by 1 minus negative 2, which is also just 3. On top, I got negative 126 divide that by 3, negative 42. And so I took the liberty of finding the 5th and 6th term, folks. So I extended the sequence or the series through 6 terms, and we add it up, you also get negative 42, so that works out. The last, and so again, please finish the odds for this section up, so there's 3 more. Remember, the answers are on the back of the packet, but make sure you're showing your work. Last but not least, things to know. The domain for any arithmetic sequence is integers greater than or equal to 1. And same for a geometric sequence, integers n greater than 1. That's the domain. That's what you can have for your input value. And then you're going to want to study your review 8.08. There's going to be 2 problems from there. Given a graph, write a geometric sequence. So you'll want to find the rate and the initial amount. It'll be something in the form of the first term value times the rate to the n minus 1. And you'll also want to find the average rate of change between 2 points. So the slope. So you'll find 2 points. Well, they're actually going to tell you, I think, what your domain is going to be or what the x values are going to be. So then you find the corresponding y, and then you find the rate of change or slope. All right, and that's what we need to know for Module 8.